IPv6 is not simply IPv4 with longer addresses. It introduces new operational behaviors and fundamental protocol changes. Addressing in v6 is tightly coupled with routing, neighbor discovery, and host configuration. Today, we're going to dissect how IPv6 organizes addresses and ensures devices can communicate reliably. IPv6 addresses types are different from v4. The three primary supported ones are unicast, that is one-to-one communication, and multicast, that is one-to-many communication, and anycast, that is one-to-nearest communication. Broadcast addresses simply do not exist. Multicast replaces them for efficiency. For example, a host sends a packet to FF02::1. That's the all nodes multicast address. It uses this to contact every neighbor on the local link. v4 would use a broadcast like 255.255.255.255. Now let's talk about the v6 representation. v6 uses 128-bit hexadecimal addresses. Addresses are written in 8 groups of 4 hexadecimal digits separated by colons. Leading zeros should be compressed. Trailing zeros, no, however. v6 supports multiple addressing scopes. So the link's local, for example, is FE80/10. This is automatically configured and mandatory on every interface. The GUA, or Global Unicast, this is from 2000::3. These are public routable addresses on the internet. Unique local ones, FC00/7, private internal use, similar to v4 private addresses. And multicast, FF00/8, those are used for one-to-many communications. A host may have link local, FE80::1C35EFF, FE6A8B2, for example, and the global unicast address, 2001 DB8, you get the drill. These addresses coexist on the same interface. So how about address assignment methods, for example? IPv6 supports several methods to assign addresses to hosts. Static assignment, which is straightforward, you configure that directly on the interface. That is usually manually configured by the administrator. Or DHCP v6, that is centralized dynamic allocation. It provides both global unicast address and additional options like DNS or network time protocol. It also supports Slack or stateless address autoconfig. The host generates a link local address automatically from the FE80 range. It can combine this with DHCP v6 for global unicast assignment or options. EUI64 interface ID generation mechanism converts MAC address into a 64-bit host portion. It splits the MAC address in half, inserts triple FE in the middle, and flips the 7th bit. This is how the address is created. For example, a laptop with MAC address of 001C3E6A0BB2 generates a link local address of FE80:021C3EFE, and you get the drill. It can then perform neighbor discovery to find routers and obtain global addresses. Let's talk about neighbor discovery because there is no ARP in v6. Neighbor Discovery Protocol, or NDP, replaces ARP and several v4 mechanisms. It rides directly on ICMP v6. The NDP, or the Neighbor Discovery Protocol, relies on ICMP v6 messages to discover neighboring nodes, determine link layer addresses, and detect duplicate addresses, and to find routers and prefixes. The key messages are router solicitation, the host asks for routers on the link, and router advertisement. Routers respond with prefix and flags, M and O bits, managed or other. The neighbor solicitation, or NS, it resolves MAC addresses of neighbors. Neighbor advertisement is a response with the MAC address information requested. When a host boots, it generates a link local address via Slack, stateless autoconfig, and it sends a router solicitation to FF02::2 to the all routers multicast address and receives a router advertisement from the router. The M flag means go to the DHCP-v6 for global address. The O flag means go request additional information from the v6 DHCP. After this, the host can communicate on the local network. One great thing about v6 is the idea of multi-homing dual addresses. v6 allows multiple addresses per interface. A host can simultaneously have a link local address, a GUA or a global unicast address, a unique local, and a temporary address for privacy. This provides flexibility for routing and security. It supports multi-homing without NAT. For example, a server in a campus network will carry a link local address, FE80, ending with 8B2, and the 2000 global unicast address, and then FZ00 private VLAN communication address. Applications could choose the appropriate source address. IPv6 addressing model is more than just longer addressing and different representation. It introduces link local addresses, hierarchical global allocation, Slack plus DHCP v6 integration, neighbor discovery for efficient network operation, and built-in support for multi-homing. This foundational understanding is critical before discussing v4 to v6 migration strategies, which what we're going to cover in the next part. Thanks for watching.